Okay, limits. Sorry for the picture because it's not that clear, but I will explain for you what is going on. We need to find these following limits. Limit of s of x, let s of x be a function, and this is the picture of it. Limit of s of x as x approaches minus 2 minus. Let's see what we have if the function is going up to minus 2 minus. It's going up to minus 2. This is minus 2. Minus 2 minus means before it reaches minus 2, right? So it is at this point here, right? It is at this point here. And y in this case, the function in this case is equal to 1. This is simple and nothing in it, right? So it is equal to 1. What will happen at if x approaches minus 2 plus? This is part B. Minus 2 plus the same. It is continuous. It is continuous function, right? We don't have any hole over here. So it's also equal to 1. What will happen if it is if x tends to minus 2 directly? Since as minus 2 minus equal as minus 2 plus, to the left sided equal to the right sided limit, this means it is equal to 1. It is continuous at minus 2. All right, he wants me to know at 3 minus, at 3 plus, what's going on, as well as x approaches 3. What will happen? What is the limit of s of x as x approaches 3 minus? 3 minus, this is the point 3, is if x approaches 3 minus from below, before it reaches 3, this means it's at this hollow point, right? So the answer is 3. At 3 minus, the answer is simply 3. At 3 plus, if it is approaching 3 from above, and 3 plus means a bit more than 3, this means at this point here, and since we don't have a hole, we have a dot shaded, so this means this is the point, right? This is the point which has y equal 0. Now, what's happening at x tends to 3 directly? As x tends to 3 directly, if 3 minus does not equal at 3 plus, so limit does not exist. This means simply as x approaches 3 does not exist. And why is that? Simply because limit of s of x as x approaches 3 minus does not equal limit of s of x as x approaches 3 plus. This is the answer of this number.